a way to look at weighing and identifying and weighing probable causes of impairment to aquatic life in a watershed. And there is obviously a range of probable or causes for impaired aquatic biology, and it allows us to tease those apart and weigh them relative to each other. And then from that, we can use that data to derive a management intervention, hopefully an optimized management intervention. There are some, as I was saying, there's a lot of new features on the IPS tool this time around, and one of them that I won't be covering much today because it's not so important to the DRSCW is the this idea of restorability and susceptibility. So at the DRSCW, we're primarily interested in restorability, as we do not have sites typically that are meeting the aquatic life goal. But for watersheds in Lake County, for example, there are a number of sites that have are obtaining the aquatic life thresholds, and so there the tool does assign a susceptibility or and threat. And what that means is it notes that while this site is meeting the general use category 4 aquatic life support, there are perhaps exceedances of chloride, say, at the site, or the site has moderate buffer or something like that, and that those are elements that the group may want to look at shoring up in order to make sure that the site does not fall south of the threshold and therefore end up on the 303B list. So part of the expansion for that has been the recognition that we had a lot more sites in this tool that are supporting. So the objective here is to have a model that allows us to optimize investments that look to improve or maintain aquatic life in area waterways. This came out of a longer objective. I took a little section of it here because I do like the way it's worded. So I'll just read that out because it feels odd not to. By quantifying restorability in a way that resources are committed to projects that have a higher likelihood of success in terms of restoring aquatic assemblages on a stream segment basis. So what we're looking to do here is that higher likelihood of success. So we will be talking about IBIs today. Just a reminder that our support is the product of meeting both the general use category for fish IBI and microinvertebrate IBI, or having one of those two moderately impaired and the other fully supporting. I'm not going to delve into IBIs, as everyone on the call should be familiar with those items. So the model does try to pull in these multiple categories of stressor, and I'll be using the word stressor to talk about things that both impact aquatic life as they increase in quantities and concentrations, and improve aquatic life as they increase in stress. They just move in different directions. Now, of course, the question then always comes that the current system works off having that the state promulgates a water quality standard that is put in place uniformly across dischargers, usually wastewater treatment plants, and then we monitor to see if the aquatic life is improving, and if it's not, then there's additional promulgation of or increasing tightening of those water quality standards. So there are a number of shortcomings with that system, but not least is that not all stressors have a water quality standard. Clearly, habitat, for example, while we know that that is a critical component in supporting or meeting aquatic life or supporting a certain biodiversity of aquatic organisms, it does not have a water quality. None of the pieces of it really have a water quality standard. But also, of course, with what we're looking at today, nutrients, phosphorus does not have a water quality standard in Illinois either. So the IPS tool does allow us to develop internal thresholds based on the empirical data that would allow us to support a certain level of aquatic organisms relative to meeting a certain regulatory goal, say general use or excellent category level of support. Now, the other thing that it does is that you may have a water quality standard, and that water quality standard could be either overly protective for your watershed, or it could be not protective enough. And the example here, I think the most obvious example here would be, say, chloride. The previous iteration of the IPS and this iteration both suggest that much lower chloride concentrations would be needed to reach general use support than what is suggested by the state water quality standard. So that's an example. Now, the other item I would point out is that the model looks at producing thresholds that are calibrated to the general use category. And so that stops the second kind of error, which is, or looks to inform us on the second kind of error, which would be that other standards or thresholds may be overly protective on what we have to accomplish to meet our regulatory goals. All right, let's move on. So I'm using these slides just to remind us of how we've used the IPS tool to date. So these are pictures from the construction of Oak Meadows. Oak Meadows was a site that the IPS tool, it scored it as moderately restorable. We went ahead and worked on the site because it was a total maximum daily load site that came out of our Qual2K modeling. There was a dam at the location that we wanted to remove. There was also a willing partner in terms of the forest preserve, and I'd just like to note what excellent partners they have been on this project. The site was noted as lacking all the QHEI components, so it lacked buffer, it was dominated by muck substrates. It did not, it was highly embedded. It had no pool depth or riffle sequences, and we calibrated the design for the site off sites on the southern Salt Creek, which were supporting for macroinvertebrates, though not for fish. So we brought those QHEI components to the design of the Oak Meadows location. This is just a summary of the shortcomings at the site, and we designed the site to overcome those shortcomings. And as everyone on the DRSCW group should be informed, site certainly looks a lot better in terms of public aesthetics. But also we did successfully move the 3 of the 4 sample sites have been moved into the meeting the support for macroinvertebrates at the location. The model also predicted that we would not meet fish at the location. Those are constrained by a second barrier further downstream. So it wasn't a surprise to us that fish did not meet the goal. In fact, it was completely as predicted. It would have been a surprise, in fact, if various fish species had started showing up here. But it does go to underline the fact that we're making these management decisions inside a very well-informed, from a very well-informed point of view. I would note, however, that fish, while the number of species did not increase at the site per se, the numbers of individuals did increase and the size of the fish did increase. So there was a impact to the fish community. And of course, once we get the downstream barriers removed, we're looking to, be interesting to see who shows up at this location. Okay, so populating our IBA. So don't need to spend a lot of time on this because we have discussed it at the DRSCW several times, but we have our chemistry data. We have our dependent variables, which are fish and macroinvertebrate population. So these are the biological community data that is dependent on our chemistry. Then we have water and sediment chemistry data. This is the more typical data that we see modeled in the various other iterations of models or decision-making exercises out there. And then we have habitat data, which we use the QHEI, which I should note Ed Rankin is the progenitor of. And then we have our land use and flow data. This is a summary, not an exhaustive one, but a summary of some of the principal types of data that was put into the tool. I should also note on the land use related, I just want to make sure that everyone remembers that Lake County GIS were Jeff Laramie and his staff were a huge help on pulling together all of this information. And we also had an intern at the Conservation Foundation, DRSCW, that we use to help generate all this information. Okay, so data sites. Previous iteration of the tool was limited to what you see as the dark green icons in there. Those are on the map on the left of your screen. Those are the DRSCW sample sites. But this tool has a lot more, between somewhere around 500 to 600 total sites. The purple are Lake County sites from the watershed groups up there, and then the light green to the south of the data set are from the Lower DuPage Watershed Coalition sites. Now, critically, all of these sites are collected in paired data form, meaning that the biology for both macroinvertebrates and fish exists, the water chemistry exists, and the habitat exists. So all that data is paired up temporally and spatially. The other blue icons that you can see on the map are from IEPA's data set, and thanks to IEPA for supplying it to us. We got, I think it was 15 years of data from them, and that really expanded the coverage of this data set. This is also paired. It's different than the data from the work groups, but it was comparable. And so what this allowed us to do is to pull in a lot of sites that were at the had more, or so we say, were less modified, which had been a shortcoming in our previous attempt at this. So the second thing is that we looked at the spatial components of these sites, so we see them geographically spread out across a map, but there's also a temporal component here. So this is data from the Salt Creek watershed for showing biological attainment. So this is the aggregate of both our fish and our invertebrate scores. And you can see here there's a difference between these two maps. This is 13 and 16. You can see some of the sites along the southern portion of the watershed changed slightly. We had one site there, SC60, that looked that in 2013 wasn't biological attainment. And in this particular case, the macroinvertebrates were meeting the threshold, but the state threshold, but the fish were not. But they were in the moderate category, so it still accomplished that. And then you can see that site had actually 2016 had slipped back, and that was because of changes in flow regime. But what I want to point out here is that because the tool is looking at several years data for a site, there's a depth of data there as well. So we can see the map, that's one component of it, but then there's also the way that these sites exist in time, where some of these sites now have 4 years of data for them. So every time the tool or the model looks at one of those sites, it doesn't look at SC29 and go, oh, I've seen this before. It looks at it as if it's a completely new engrammination of the biology, chemistry, and habitat and landscape variables. So we get to compare how that changes through time, and that informs the model on how the stressor and the dependent biological variables are interacting. So the decision-making part of this tool that we're going to look at is part of a larger process of decision-making and implementation. The adaptive management mindset, which is a plan, do, review, learn from that, and then integrate that back into your planning. Of course, Oak Meadows would be an example of that, where we, on one level, we learned something about constructing those sites, and there would be changes that we've used at the Springbrook project, for example. But also, how did the biology behave as advertised? Are there things that we have learned from that? Are there things that we may do differently at, say, the Growy Mill Fullersburg Woods site? So here's a flow diagram showing the principal points of how the IPS is run. So obviously it starts off with the data set that we covered. That's the paired stressor data and biology data. The first step was looking at deriving these sensitive species out of the data set. We'll look at how that is done. Those were then used to inform the identification of thresholds after we confirmed that they correlated well with our IBI, general use IBIs. We then take those thresholds, and we also then weighed out the various components of stressors. How were they important? Not just did they correlate well with the biological responses, but also how they weighed in terms of their impact on biology relative to one another. So sensitive species. This is relatively new. A way of or technique. So there is a good relationship, as we've seen, between a lot of our principal variables and fish and insect IBI, or even an aggregate IBI of some kind of those two. And that would be expected. For example, the previous IPS tool, we looked at quantile regression of IBI against various stressors, be they the chemical or habitat stressors, and we find very good relationships in nine variables. So one of the changes we did here was then we developed these sensitive, I'll call them sensitive species here for the fish, but obviously sensitive taxa for the macroinvertebrates as well. And how this was done is we looked at the weighted means of individuals of all of the species present in the data set as the stressor variable increased. So as you can see in the bottom right plot, QHEI, as you know, as QHEI increases, the number of fish species increase, but also there are certain species that cluster towards the upper end of that relationship. So these are ones that are more sensitive to changes in QHEI. So then we can build if you like, a QHEI sensitive IBI out of that. Now, we have to make sure that that does not move away from a relationship with our fish IBI, because obviously our end goal is to move these waterways into compliance with the Clean Water Act, and that is the regulatory goal is general use biology. So then the upper plot shows that the relationship, that's a regression between the QHEI sensitive species and fish IBI, and you can see once again we have a very good relationship there, and we can see here that it's about 6 species is the equivalent to 6 species from that QHEI sensitive fish species group is the equivalent of our, or it has a, nearly a 90 or 0.98 R squared correlation with our fish IBI. Okay, this is another data plot showing the same kind of work, but this time with a chemical stressor. So you will notice here, actually just going to flip back to the previous one, you can see here that the way the data is piling up in the right-hand side of the plots. And that's because QHEI is a positive stressor. So as the concentration of QHEI goes up, QHEI score increases, the biodiversity increases. So better habitat, better species biodiversity, what we'd expect. Conductivity is a measure of the electrical conductivity of water. As the ionic loading increases, conductivity also goes up. So it's an excellent proxy for chloride and such. As that increases, species go down. So you can see on the bottom plot, you can see there that the species are clustering towards the left-hand side of the graphic. In fact, species diversity is falling off as conductivity goes up. But once again, that reverses then on this particular example with fish IBI and conductivity fish species, because we would still expect to maintain that good correlation between our fish IBI and the conductivity sensitive fish species. So once again, as our fish species increase, the conductivity sensitive fish species are also increasing, and the relationship is a very good one. I don't have the pointers on this one, but once again, you could see that it would be about 4 score of 4 for those fish species that would be relative to our fish IBI of 40. So to each one of these stressors, we attach these narrative rankings of excellent through to poor. That allowed us a kind of normalization within the model, which allowed us to assign, this stressor variable, QHEI is measured on a 0 to 100 type scale. This allowed us to normalize it down to a sort of a 1 to 10 type value. If you think again about chemical variables, such as going back to chlorides, milligrams per liter, once again, it then gets sorted into one of these baskets where it would have this set of concentrations falls into a basket which is in our 8 to 10 category, and that correlates very well with the probability of falling into the very poor. So this is a look at imposing these narrative values onto the data set, once again for chlorides. So we can see our chloride and our sensitive fish species, once again, then falling away steeply as chloride concentrations increase on our left-hand graph. And then these various lines, yellow is for very poor, all the way through to blue, which is excellent. And you can see once again that that's increasing, and we can see that those narrative values are falling within the data set. So a better way to look at this is like this. This is a probability plot. So we have these sensitive species we've derived from quantile regression that we were looking at. They are then put into these points. And so these are a mix of general IBI and sensitive species distributions. And you can see here then they're, where they're present at the site, that site then is assigned if it's meeting the aquatic life goal or not. So we have our blue running along the bottom, which are the sites that are meeting. They're in the excellent category. And then moving up through all the different iterations all the way through to very poor. And you can see here what was done was then that the top at the 75th percentile, we then had a number of sites after that. And when it fell beneath a certain number of the sensitive species that were appearing inside that group, we excluded those from the data set. The reason for doing that was that it could be anomalous, some of our readings for the site, but it also is likely that while the site is meeting, it is being subjected. I mean, all sites in Illinois are subject to a certain level of anthropomorphic stress. And so this was a way to make increase the probability that the threshold that was identified was accurately or had a higher probability of being indicative of the site supporting the aquatic life attached to it. So these then could be broken out into different levels of chloride concentration in this case to support those various levels of attainment. And you can see here along the bottom of the screen we have chloride concentrations. The box on the right-hand side is the reference reach. So you see there the mean and median from our reference reaches. So these are the sites with the lowest level of anthropomorphic stress. So our mean value there was 123. And just for people who may have that question, all of these values are collected during the summer. These are not winter values. And just given there's some discussion around winter and summer values, how they're relative to the impacts on aquatic life, these are all summer values. This data was all collected inside in May through to September timeframe, probably more actually even of a June through to August type line.
Stephen.
So, yes?
We have a question about the thresholds. Is wondering, are those acute or chronic thresholds, and how would and if so, and then what would the length of time that they would be based on if they were like?
Yeah, that's a good question. I might even ask Ed to weigh in on that, but I would specify that these are more like chronic.
I am muted, Ed, so he can talk.
Okay.
Yeah, I would agree. I think they're more like chronic. In other words, the response is based on summer sampling over a course of a season. That's how we measured the chloride data. And if you look at the literature, especially in northern areas, there's a pretty good correlation between summer levels and then the winter early spring melt levels. In other words, if you're getting, the idea with these numbers is that number of that chloride number, say for a good stream, 120 milligrams per liter, that's less than the 250 milligram per liter chronic level of that EPA derived from laboratory testing. But if you look at correlations, once you start getting above 100, 120 milligrams per liter in the summer, that's correlated with exceedances of that 250 milligram per liter chronic level in those winter periods. So you can use the summer periods. We're not saying that necessarily the 120 itself is a if you never want to above 120, it wouldn't necessarily be causing the damage. It's correlated with winter values and spring values that are above 250 or more. So it's because there's a good correlation between summer and winter, we can use these thresholds, because that's when we're actually out doing. You don't have to be there at that peak event. You can look at what's left behind in the summer period to estimate your risk of causing a chronic impact from those winter periods.
And I think that goes to the point about the difference between empirical field data and in lab data. We just can't crank the summer chloride levels up to a level where fish die and they'll go, that's what we're observing in this data set. So we're trying to derive these relationships from observing real presence and absence in a field condition.
And there's another question about how do these work? Like, why is the fair at 175 greater than the poor at 168?
Ed, are you still on? Do you want to address that?
I'll have to check that. I'm not sure why that. They're usually not done that way. It's possible that for whatever reason, see, once you get below the good and excellent range, you tend to get you tend to get a lot of sites with a lot of multiple stressors. So it's more difficult to separate out the thresholds. But I'll probably need to check on that one. Usually they do sort of follow a increasing level as you go from fair to poor to very poor.
This one's somewhat atypical in that thing, but just like one again to reiterate that this was the example that I was using for pointing out that this is an area where the IPS tool would suggest that the water quality standard that we're working under is not protective enough. Okay. So this is another way of looking at this. This is a box and whisker plot showing the same data, but just kind of flipped on its side. So once again, you can see there that's the chloride concentrations on an upright y-axis, and then the IBI baskets, as it were, along the x-axis. And then our green is our general use category, and you can see the data set there, how it falls into it. There are a couple of outliers on the upper end of the green. That's the good IBI box and whisker plot. So those are sites, for example, where we're saying, well, yes, it is meeting the general use, but we do want to pay attention to chlorides at that site because those may become an issue that would push it down into the fair IBI case as that's would be a managerial output from looking at this data.
Stephen, just trying to. Chris won't let me unmute him. So Chris had responded that these are not final values, that the values have been revised to less than 40, like 40, 120, 184, and 249.8.
Yes, and I apologize. My slide has not been updated to show that. That's a slide from an earlier presentation.
Then I did unmute Chris if he wants to correct me on that. And we had another question about what are the sources of these chlorides in the summer in these streams?
So, well, before we jump into that, Chris, do you have anything to add? You were just talking about those values, or I think Dean already covered it.
No, that's an old slide. And
okay, yeah, and that's my bad. It's gets
you do
easy
have a complete table of final values.
Okay.
If somebody wants to see those before we get.
I'm making a note here to update it. It's easy to just slide slides that you put together already into the presentation.
Yeah, that slide's about 2 years old.
Okay.
So Generally, these things do follow a logical progression along that gradient. The only thing we found was in some cases it was not possible to distinguish excellent from good because we didn't have enough data from excellent sites for some parameters. So one thing people need to understand is we did not have a perfect data set.
No.
And that's just the nature of the beast when you have to deal with data collected by somebody else. But that would be the only kind of aberration that you might see in this gradient. And where those occurred like that, we had to call them the same thing. So you can unmute me if you want.
Okay.
All right. So the second question then was, where are chlorides coming from in the summer conditions? So what we've done is we've taken the chloride data from our summer sampling and we've plotted it out against time. So it's not geographically controlled, it's just a temporal distribution. And what we see is you see a large tail on chloride. So, you know, you're maybe starting out around 250, 300 back in March, April. And then getting into May is going down to 200, or rather like 250, and then it tails away all the way through to October, continuing to decrease, and then it spikes up again in around the beginning of December. We have our first call out, and snow fighting crews get out on the road, start applying salt, and it immediately shoots up to 600-700, stays there for the majority of the winter with some spikes around 1,000. Milligrams per liter or such. So what this largely is residue of salt on the road. And I realize that may seem incredible, but we did collect salt from our street sweeping debris last year. This was street sweeping done in April, and we were finding between I think it was between 300 and 800 milligrams per kilogram of chloride in that street sweeping debris. In fact, when you take a closer look at the road, you will find salt debris on the road visible to the naked eye. The salt is just hanging around the system after the winter. It's not like we do our final call out in April, say April 1, and then it's next day, 24 hours later, it's gone. It is leaking into the system over the spring and into the summer and right through into the fall. In decreasing quantities. And I'd say, I suspect that when we get into October, the floor at that point is being set by the wastewater effluent, which tends to have a higher chloride concentration than stormwater at that point. But up until that point, the wastewater effluent is actually moderating the inputs of stormwater. So it's a complex picture, but it does suggest that perhaps we need to look at trying to target getting those chlorides down in that late spring period, so they have less of an impact on the breeding and feeding cycles of these bioorganisms. Anyway, that was a longer answer than probably the person anticipated, but I think that should cover it. Okay, this is a probability plot once again then for QHEI, and what I just want to show here is with the positive variables, we flip these on their head. So we saw the different clusterings in the left and right parts of the quantile regression plots. Here you can see that it's flipped upside down, and now the excellent sites are up at the top of the graphic. And this one here has the thresholds have a much clearer progression. Once again, this slide is old. I'll have to go back and check the threshold values coming out of it that they hold up. I just really should redo these slides with the latest data. So getting back to nutrients and decision making on nutrients, these are the slides for nutrients. And just one of the things, and Doug will talk about this, is that the relationships with nutrients do tend to be they're not as strong as the relationships we see with a lot of QHEI data. And we've talked about that in the past. You can see that we refer to the shotgun effect, where it looks like you've just taken it would be a pretty big shell, but a top right-hand quadrant. and just shot it at a piece of paper. It's hard to see. That's total phosphorus plotted against fish IBI, and you can see that it's really just eyeballing. It's hard to see any kind of relationship in there. But I did think it was of interest to perhaps look at one of these sensitive species distributions that we're using to inform these decisions and fine-tune those thresholds. This is the, I left the title off this. This is the distribution of species with total phosphorus. So this would follow like our probability plot. So we're looking at the ones at the bottom left-hand side are the ones that have been shown most sensitive, and then the ones at the top that's the river carp sucker through to common carp and goldfish. No surprise there that those guys are in the category, but those are the ones that are showing to be the least sensitive to changes in phosphorus. So these plots were produced for every pollutant that we looked at, every stressor we looked at rather. So then after these thresholds were derived and certain stressors were found to have a very strong relationship, other ones were having a weak relationship, there remained the question of, well, how do these stressors interact with each other? How are they of importance relative to one another? Because one of the decisions that groups that are looking to manage waterways to have better biological outcomes is, that if what is the relative impact of, say, chloride versus putting in a riffle, say, in a river? Which one of those would have the biggest impact at a site, reach, and watershed scale? So this tool was used to weigh the importance of the different variables, and it is called a random forest technique. So this is not a technique that I have used, and it was a new one to me. I have read some papers on it, but I don't claim to understand it any better having read those papers. But from my understanding, this is kind of like the regression trees that we're more familiar with. And it is a whole forest of such trees, and so you've got a much larger combination of the way the data is put together. So and then the forest selects the trees that are the best ways of explaining how those data flow through the breakout of organisms. So the way these would work is, you have say chloride impacting your fish community. So we can see a break point at a certain concentration of chlorides, usually very similar to the thresholds that we were breaking out, but these ones would break out into in a binary way. And then you would have other items come in to inform that, such as it also correlates well with road density, which you would expect in sites that have or perhaps commercial and industrial land use, where you'd expect to have a higher use of chlorides on road surfaces. And so it breaks down each of the pollutants or all the combinations of pollutants, and it stressors, and it breaks them all the way down to your explanation. We did this in a few different ways. This is one of the tables showing this, and this fit score. So as we deviate from 0, then the variable becomes a worse or a less heavily weighted variable in explaining the biodiversity in the observed at the sample site. So how does this data line up with our previous quantile regressions and threshold analysis from our previous iteration of the tool? So here I've got these are the 9 variables that are showing to be statistically significant. Now the current tool has a wider range of variables that fit in here, so this is not the exhaustive list of the ones that it weighted to be statistically significant. I thought it was important to match these off, and as you can see, I think the previous iteration holds up pretty well. I've got the outputs for both the fish and macroinvertebrates from the older tool. Those are the 2 gray columns on the left, and then the new IPS thresholds are shown on the right. And what we're showing there is the ones that were proved to be the most sensitive. Interestingly enough, I think that typically, if I remember correctly, it was the macroinvertebrates that showed up being the most sensitive on our previous iteration, and it seemed fish dominated in this particular tool, and that may be a reflection of the wider range of sites and having more sites in the good and excellent categories. One of the things we had in the previous tool was because we had impingement by dams on a number of locations, fish were just not present at a lot of the locations to sort of measure the response in an accurate way. So at the upper ends of some of those sites, that relationship was getting a little tough to look at. All right, nutrients. So one of the items that come out of this was that we did establish a relationship between biology and total phosphorus, which we had not done in the previous tool. This could be because of our use of the sensitive species. It could also be coming out of the wider range of sites. The general use threshold corresponded with a breakpoint of 0.28 milligrams per liter total phosphorus. This table shows that value along with other values that will be in the documentation from the model, showing the data coming out from EPA and Ohio EPA and other sources. The model also generated, thinking about going on and informing our work on nutrients. These are other, we're calling primary variables and secondary variables. So these other values come out, once again, calibrated to, I haven't included all of them here. They run all the way through to the poor, but I've just included the excellent, general use, and fair here, give people an idea of what we're looking at. But it also shows the what things like QHEI, et cetera, also correlated quite well it correlates quite well with a lot of nutrient issues. And that I think to have a comprehensive NARP would have to include all of these elements. So this data then obviously brings the work group to a decision-making point that we felt we needed. There was going to be a level of scrutiny on a lot of these items, and at that point we sought out to have some independent evaluation of the nutrient components of the IPS model, and that's when we asked Kaiser and Associates to review that independently and give us some feedback. These are just Power BI outputs from the model. I'm not going to go through these last few slides. They were for demonstrating folks who had not really seen IPS before. But I'm just going to flip through to the final slide, which is our ongoing project. This is a project working with the Illinois Tollway and the Forest Preserve District, DuPage County. This is an aerial image from the site at the end of March, and it shows the meandering corridor there is what you can see. If we go back to our previous slide there, this is what the site looks like. You can see the orange points mark the, obviously this is a foliage on image. You can see the corridor. This site was recommended for a lot of channel work and increase in gravel substrates. And you can see there the remeandering work that is ongoing to introduce to up those channel scores. And of course, there's riffle sequences there. You can see those little light triangles, those mark bank conditions that are there to support the abutments of the riffles. So that is the end of the IPS update. So now I'm going to hand over to...
We have a couple questions.
Okay.
So the first question that I have is that says, if TP is not well related to MIBI and FIBI, is it fair to determine the thresholds based on this methodology?
Well, so when I say not well related, I would say that the relationship we found was not as strong as some of the other relationships, but it was still strong enough to merit an exam or attention. And also phosphorus was also weighted as being by the fit model. That's the sort of the weighting of all the various variables it was still, it was in the upper category. It wasn't the top category, but it was in the upper categories of that model's output as well. So just to be clear, there was a relationship. It was just not the strongest one observed in terms of the relationships between biology and stressors. In fact, I think, Ed, does that seem a fair characterization?
1 second, I need to unmute him.
Yeah, I realize that.
Okay.
No, I think that's fair. I think there are it was weaker, but there were places where it did seem to be some response. So it just wasn't as it didn't rank quite as highly as some of the other parameters by itself anyway. Now we did when we combined multiple nutrient parameters, for example, that we did a nutrient stressor index that basically looked at places where we had high phosphorus, high TKN, high nitrate. There was a little more predictive. Again, there were places where they looked like there were some pretty strong effects, but they weren't nearly as strong as, say, some of the physical effects that we saw. But still, I think useful enough to at least to consider that when looking at where do you see these the more extreme effects of nutrients, and particularly when I think the goal of a lot of this is where you have multiple stressors. Are there and that's why I think there's a focus on a lot of the habitat stressors, since they are related to nutrients. You may be able to deal with some of those worse nutrient effects by focusing on some of the habitat components that may help moderate some of those impacts. So.
Okay.
That's all the questions that I have so far. So I don't know if anybody has any other questions that they would like to ask.
Yeah, and we'll also have time for a discussion once Doug and Mark have run through their slides. So with that, then I'm going to at the moment I am going to stop sharing.
I took your screen. Did
you have possession of?
Yeah, I've got it.
Okay, good. Because I don't know what else to do. I was out of options, Dana. A button or bust.
Hold on, let me share this. I gotta unmute them.
I'm going to introduce our next speakers. So we have Dr. Douglas McLaughlin. He is a science advisor with Kaiser & Associates with over 30 years of experience in water resources. He has his PhD was on PCB, natural induced transformations of PCBs in Great Lake sediments. He joined Kaiser & Associates 2018, and he had spent 15 years as the principal research scientist at the National Council of Air and Stream Improvements. And that is a nonprofit environmental research group which supports forest products industry. And that's actually where, while he was working there, is when I first met Doug. He served on a number of state and federal regulatory boards, including relatively recently, the Illinois Nutrient Science Advisory Committee, which, as we all know, was working to develop numeric nutrient water quality standards to protect aquatic life in Illinoisan waters. Other speaker is Mark Kaiser. Mark is the senior scientist and principal of Kaiser & Associates, LLC. It's an environmental science and engineering firm in Michigan. People will have seen Mark's name before and recognize KNA. They are one of our contractors on our trading program that we are hoping that is going to be linked to the IPS model and look at rationalizing how we work our way through the nutrients, but also the other sets of stressors out there. I think, Mark has definitely been a pioneer and a leader in U.S. water quality trading program and policy development, and he's had a very impressive resume on trading, having worked on it in 4 continents and nearly 30 states throughout the USA. He holds bachelor's and master's degrees in biological sciences from Wittenberg University, Ohio, and from Michigan Tech at Houghton, Michigan. And with that, welcome Doug and Mark and let you guys take over.
Mark, hi everyone, this is Doug. Mark, do you want to say a few introductory comments?
Thanks, Doug. Thank you, Dina. This is really, I think, what's kind of on the cutting edge here that we see in the country is there's been a push in the last couple of years to try to move these relationships between stream conditions and, if you will, point source loading a little bit closer together, this idea of compliance, alternative compliance approaches. And my sense is, based on what we've seen across the country, the work that's being done here in Illinois, and these are some of the most the strongest databases to begin to look at some of these biological factors, biological conditions that can relate us back to what would happen if alternatively there were nutrient loadings into the stream. So this is really kind of out on the front edge of this, but this was such a strong database, and this IPS tool that's being developed here, that's being refined, this is really kind of out at the front of the pack. For the most part, what happens in these programs is we tend to see a fairly minimalistic or the most simplistic approach to calculate benefits associated with on the landscape types of changes that result in some form of reduced nutrient loading. Often we work with the agricultural sector. You may have some fairly simplistic empirical models that say, well, here's our current condition load. If we implement a conservation practice, here's the new load. And the difference in that computation becomes what's traded. And so in those cases, you're trading the lake for lake. You're trading nutrient loading that's occurring in the landscape with the nutrient load reduction requirement that is maybe associated with a wastewater treatment plant that's trying to use and purchase these alternative source load reductions. In this case, this is a kind of an obvious difference because it's not necessarily trading like for like, but the notion here is if we can establish the equivalence of a lot of these in-stream improvements with what the actual load reduction benefit could be at the source. Again, what we're trying to do is what is the most effective means to getting towards that clean water act goal. So again, this is kind of out there on the front edge. This is probably one of the most sophisticated approaches in looking at this. Sophisticated from the standpoint of the data set that's available, whereas other programs that are looking at this lake for not lake types of exchange are still using some of the more simplistic approaches to assess what are some of the relational benefits without this direct tie to the biology. So as we took on this idea of reviewing QHEI and the IPS tool in these relationships, we recognize that it's out on the front edge, that because of the amount of data that are available, this kind of inherently makes this a little bit more of a complex analysis, but a complex relationship. But as Stephen has shown, a lot of the relationships that are being developed, I think that's where the heart of this lies in terms of the strength of the data set and the potential to really come back to this idea of treating lake for unlike. And that's not to diminish the, our Clean Water Act needs for nutrient controls, but rather where are we getting the best, where do we put our financing to get the best return on pollution control. And so again, I think the tool is beginning to show us a lot of opportunities. Doug did a pretty deep dive into a lot of these relationships. And I think, Doug, with that, I'm going to turn this back over to you. I'll mute myself. And if you walk, we've just got about 6 slides that Doug will walk through, presenting on our specific analysis and some of our findings. And then, Stephen, we'll turn it back over to you for questions.
Okay. Again, my name is Doug McLaughlin. I'm going to presume that you can hear me okay. A couple of introductory comments, maybe a little more with respect to the work that I've been involved with relating to the development of nutrient benchmarks and water quality criteria and standards. It's a topic that I began to dig more deeply into in the probably 2007, 2008 time frame. And one of the big questions as US EPA continued to push for the development of numeric criteria for nutrients in particular, the role of field data become really important, and the effort to characterize field data in a way that yields useful criteria, useful thresholds, useful from the point of view of the decision maker who needs to identify the likelihood of a nutrient impact, and then use that information in remedial actions or preventive measures. So my involvement with the topic has been fairly extensive over the last 10 plus years. That ended up, I think, bringing me into the NSAC process, the Nutrient Science Advisory Committee in Illinois. I was one of 6 panelists beginning with the process in late 2015. And my involvement actually came to a close just prior to the completion, several months, but prior to the completion of the effort in 2018, as I took a new position, moving from the National Council for Air and Stream Improvement to Kaiser and Associates. So I was deeply involved in the NSAC process through nearly the completion, but not all the way until the end. So that is just a little bit more perspective about me and the position from which I reviewed the IPS model system. So the charge that was put to us is characterized here specifically to evaluate the scientific aspects of MBI's modeling system in relationship to its ability to assess nutrient related impacts in streams of Northeast Illinois. So a specific focus on the nutrient related components that of course required a deeper dive into the model itself. I began this task, I would say, in the September 2019 neighborhood. The review involved an examination of several draft chapters of the IPS technical support document, and a number of other documents and files were provided along with that. The review ended up in the form of a technical memorandum that was provided to the Conservation Foundation early this year. Okay, Steve. So that's a small number of slides I just pulled out some key bullet points to try to give an overview. Of course, the technical memorandum is available and contains additional detail. But in general, the primary conclusions were that the IPS model is useful, it's science-based. And again, this is with respect to nutrient components of these stream ecosystems, can be useful in the kind of management context to identify restoration projects, yield to conclusions about protection of beneficial uses as it relates to nutrients. I find it to be a valuable decision-making framework. There are opportunities for further refinement in the future. This is something that the model authors also acknowledge and have some specific ideas for as it relates to improving information on nutrient impacts. And the IPS model operates at several geographical scales. And so there's the overall uses of the model and what the intended uses are is a key component of how to think about this model. I attended the school of thought that all models are wrong, but some are useful. And so whether or not they're useful is a function of what their particular intended uses are. So that's an important consideration here. Next slide. Some of the strengths, clearly the multiple years of field data from the particular watersheds of interest, that's very important. Let me step back just a brief minute to say the challenge here, as I mentioned a little bit earlier, is how do you develop meaningful numeric criteria from field data? This is a different scenario than being in the laboratory or even controlled mesocosm studies where you can more clearly look for responses as a function of increasing doses of chemical of interest. So it is it's challenging to begin with, but there is precedent for it. And, you know, science has benefited from field data for a long time to try to pull out relationships that are meaningful in water resources management. So the fact that there are multiple years of data is clearly a strength. One of the other strengths clearly is that there is a focus on multiple biological endpoints and a wide range of potential stressors. Clearly, when it comes to understanding nutrients and whether there is a problem or not at a given nutrient concentration, the biological responses are important. They're important in science context and ecosystem management context. They're also reflected in the way regulations are oriented around water quality criteria. The biological piece is important, and that's particularly the case in the development of phosphorus and nitrogen criteria, for example. There's a systematic approach taken with these data to develop causal relationships, basically building weight of evidence for causal relationships. The stressor benchmarks for nutrients and really all of the stressor benchmarks contribute to that weight of evidence. And as I looked at the range of nutrient thresholds or benchmarks that are identified, these are in a range that I'm familiar with, in particular with the work from the NSAC committee, where we looked at field data as well as reference information or information from reference streams. We looked at literature values. a range of sources of information for informing nutrient thresholds. So the range of values that I see in IPS seems reasonable. And the approach overall struck me anyway as being similar to the kind of relative risk assessment work which has been published in the peer-reviewed literature. Next slide. I identified a number of potential concerns, areas that, there may be a range of significance and also opportunities to address these particular concerns. Again, what I reviewed was information that was available last fall. So that's several months ago now at this point. But clearly, and again, I'll say the authors identified this concern. I think it's an important concern, one that the NSAC also identified, not insurmountable, but the fact that there are not a substantial amount of data at this point on algometrics or surrogates, including deployments of continuous DO data collection, sensor deployments, for example, is a limitation on the ability of IPS to assess impairments, specifically as it relates to nutrients. The tech memo goes into that in a little more detail. One of the main opportunities, I'll say, that algometrics provide in the case of understanding nutrient impacts is it's right smack in the middle of the conceptual model of how nutrients affect ecosystems at the macroinvertebrate and fish community level. So it's an important data type, which my understanding is going forward, more of these kinds of data will be available or will be collected and potentially and made available for use. The second item, the species sensitivity distribution approach, at least my takeaway from how that approach is being used, I think it's, at least from my experience, fairly new in terms of how to look at field data. It's not brand new. It was a significant, in fact, the major approach that EPA took to develop its draft conductivity standard. And there, I was actually a part, and I think Ed was as well, a part of the science review committee that looked at EPA's draft documents. And the general takeaway was that it's an appropriate, the general takeaway, let me be as clear as I can, from that particular review committee was that it's an appropriate technique, but there are some specific elements to it which are important, especially as it relates to defining cause-effect thresholds. In other words, assigning cause to a particular pollutant. Another takeaway for me was that it would be valuable for there to be a more thorough description of correlation between potential stressors. I think that would improve the weight of evidence support. What I mean here specifically is from field data, this won't be a surprise to anyone on this call, but the challenge is to get it right with respect to what is the cause of the biological impairment that's being observed, and several pollutants can move up and down together in terms of their concentration or their potential impacts. So and field data, trying to tease that out from field data is a challenge. a lot has been done in the development of IPS to get at that. But specifically, I think more can be done to describe how, for example, total phosphorus concentrations across a range of sites is correlated with conductivity, for example, or chlorides, or total Kelvin nitrogen, for example. That would help narrow the degree to which some pollutants may be moving around together, complicating the cause-effect picture. And then the fourth item on this page, clearly habitat degradation is a significant stressor for both macroinvertebrate fish, macroinvertebrate and fish communities. It may have an impact on limiting the IPS sensitivity to nutrient impacts. There's QHEI is a big hitter over a lot of the data set, and so there may be some nutrient impacts going on within that that are hard to pull out. This is something that I think can be looked at in a little bit more detail. Next slide, please. Just lost the slideshow. Is that just me?
No, I'm working on it. Sorry. There,
Okay.
As I'm answering questions and looking at other things, I click off of it and things get a little goofy.
Right. Okay.
But I'm trying to get it to. So we just have the one left. Okay.
Yep, that's the slide.
Now I went back to this one. Sorry about that.
It's okay. A few recommendations identified. One I've mentioned already. Working to include primary productivity metrics, specifically algal abundance, chlorophyll 8 concentrations, other kinds of algal endpoints, and specifically for the wadable streams, benthic, algae, although cystonic algae may also be useful. Filling that data gap in the biological responses, I think, is an important thing going forward. Weight of evidence would benefit from a more detailed description of the expected nutrient impact mechanisms that account for observed patterns of fish and macroinvertebrate taxa presence and absence. So in other words, I think there is room for a more complete description of how nutrients are expected to modify the macroinvertebrate taxa community and the fish community. What community structure changes, what species changes are expected when nutrient concentrations go up and down, and what are the mechanisms that are relevant to individual taxa or groups of taxa, individual taxon or groups of taxa. And then the last point here is there may, I think, be some opportunity for additional model validation using either existing data or data that are collected in the future. I think here the opportunity is to better understand the performance in terms of false positive and false negative errors of the IPS model across a range of the excellent to poor thresholds. I think it's easy for all of us to understand, especially looking at the degree of variability that is in some of these plots, that it may be well, it's more likely to make a mistake distinguishing a fair situation from a poor situation then it would be to make a mistake distinguishing an excellent condition or an excellent situation from a poor or very poor situation. And I think there are opportunities to quantify that that it could be useful to the community of people who are going to use the model as well as use the results of the model. So with that, that's the brief summary that I intended to provide. I'd be happy to try to answer questions.
So far, I only had one question submitted, which I was able to answer. And that question was, has the tech memo been released? And that we will be sharing it soon with our partners. We were waiting for after this presentation to be done and our discussion to have before we went ahead and released that memo. So if anybody else has any questions, you can type it in the Q&A or the chat, or you can raise your hand if you'd like to talk, and then I can unmute your mic, and then you'd be able to ask our presenters any questions. And we have them all available. Doug, Stephen, Chris, Ed, and Mark are all here.
Hey, Dina, this is Mark. As maybe you're waiting for a few questions to come in, I think kind of encapsulate or capsulize where Doug has done his review here, and then in the context of this broader notion of alternative approaches to achieve our water quality standards or our Clean Water Act goals. What's fascinating about this approach is it is very data driven, whereas in most of the other programs that are more of the, if we think about the traditional water quality trading, these tend to be more estimated or model estimated approaches. And so I think therein lies another great benefit of being able to have these intense data sets and recognizing there is uncertainty because biological systems can be noisy. I think a comparison is useful that when we talk about our more traditional approaches, where we might be looking at nutrient reductions through agriculture, there's a lot of uncertainty and variability in estimating those systems as well. So again, I think that comes back to the data-driven process here, as we've got a much stronger handle on being able to maybe characterize some of that uncertainty. So again, that's a prevailing thought that we've had as we kind of consider both of these approaches with how this IPS tool might be used compared to what we typically may do with some simplistic model estimations.
So I have a question about cyanobacteria and how, if that was looked at here, I'm like, has this model been used, or even possibly could it be used to address any of the recreational uses? And I've unmuted the MBI folks. Steven's unmuted. So
Thanks.
anybody who'd like to take a stab at that?
Well, if we start with the recreational uses, I'll defer to Ed on his thinking on that.
Yeah, we haven't, I mean, we do assess recreational uses when we do our surveys and so on, but we haven't necessarily, again, it's probably a deficit information on some of the toxic components of the HABs that may be there. I mean, we've wondered in some places in Ohio where we've worked whether there are some HAB issues, whether some of the response, like some work we did in the Little Miami River, which was a high quality river, whether some of the response to some of the sensitive organisms, is it a response to some of those sort of increased algal cyanobacteria or toxics, and again, we don't have that sort of information at our fingertips like it would be nice to have to include.
Yeah, and it's sort of at a lighter level. One of the things I would point out is I think some of the projects that have come out of the IPS tool from a river recreation point of view have been pretty successful. We've got, I realize, I'm not talking about the, catching and eating fish or something like that, but just in terms of canoeing, etc. I think that the QHEI projects have definitely, we don't have a QHEI score for recreational attainment, but in that sense, but certainly the feedback we've got from anglers and have been very positive.
Can you hear me?
Yes,
Am I on? Okay.
you are.
There's a couple angles to that. This is Chris Yoder, by the way. We haven't looked at it, and I think the perception is that smaller streams don't have HAB issues, which I think is a risky assumption these days. And we tend to think of those only happening in larger water bodies where there's enough retention time for the toxic algae to get going en masse. But we're potentially seeing those outbreaks move upstream. And I think it is worth being aware of. It's another cost item to analyze for. But I think it has merit for future considerations. And it's something we could, you could easily build into your program. The other issue with recreation, we always tend to think of bacteria. And the only place we have done a recreational assessment for bacteria exposure is in the upper Des Plaines set of water bodies that we've been monitoring since 2016. And there we're using E. coli. And because Illinois doesn't have an E. coli criterion, we have to use the federal criterion. And yes, we do see some issues, especially in the smaller water bodies. So that's a whole nother issue. And I mean, it gets into this domain of designated uses. We're focused on aquatic life because it tends to affect all management issues, but it doesn't mean recreation is any less diminished. So if you want that done, it's going to add another layer onto the entire program.
Yeah, and Chris, just picking up on the point, the IPS model is focused on aquatic life improvement. It is the primary driver of the permits from the groups that funded its development, and it was answering the question that was asked by them.
But I think it's an opportunity for this group to once again exert some leadership in Illinois, and that I really don't expect I don't know. Well, I shouldn't say I don't expect. I don't know what Illinois EPA is doing with it, but continuing to rely on fecal coliform, which does, that's an extremely noisy recreational risk indicator.
Yeah.
E. coli is bad enough; it has its own problems. So.
Just to make everyone aware, the DRSCW has started fecal coliform sampling at priority sites, getting an actual 5 and 30 sample during the sampling window in each of the watersheds. I mean, it's not at every site, but we're doing about 7 sites in each of the watersheds on the main stems and major tribs.
Dina, this is Mark Kaiser. Just the conversation around bacteria, is the question here more around other sources, diffuse sources of bacterial loading that, granted it's an important recreational consideration, partial full body contact, is that a little bit extraneous to the idea of what the wastewater treatment plants and the in-stream restoration investments are focused on?
I mean, I'm not going to speak for the questionnaire. If he'd like, I can turn his mic on if he would like to clarify. I'm not actually, sure. I think he was looking at, like, especially with these phosphorus thresholds and things like that, are we looking at the protection of HAB blooms, you know, in our streams with those thresholds? I think,
Yeah. I suspect that the question is can this methodology be adapted to, you know, if we had data on those, could it be adapted to that use? And of course, the thing is here, our dependent variable, you know, is the aquatic organisms. So certainly the mathematical tools could be adapted to that, but the way this particular model is set up at this time, it is focused on using out those causal relationships between aquatic ecology and the various stressors, rather than a human recreational component. But you know, if you would have to collect data on the variables to pull into this to answer that question.
We found just the E. coli data itself, where we've collected it, to be informative about potential sources of organic enrichment that correspond to aquatic life impairments. And so I think it has some usefulness beyond just the, you know, the recreational exposure thresholds.
Okay. Okay, I have
so the question was, he was focused on nutrients and whether the model addresses nutrient pollution that causes HABs, and he thinks we answered that.
Yeah.
I have another question that if the thresholds were created using sensitive species presence at reference sites, is there concern when you apply these to sites where those species are not found?
Let me take a crack at that.
Okay.
And then Ed can add into it. But it wasn't just done at reference sites. Naturally, those sensitive species are going to be present force at the highest quality sites, and their weighting is going to be highest at those sites. We acknowledge that. But where the thresholds were set, the relationships of the sensitive species distribution was snapped back to the Illinois IBIs. And the reason it was done is that's the correct way for assessing impairment in Illinois streams. I mean, we can have a whole nother debate whether those are any good or not. Having used them for about 15 years and having done some pretty in-depth evaluations of Illinois' program, the indices themselves are pretty well constructed. And so without getting off on that tangent, which I think is important for a couple other issues down here later on, but so you can get attainment of the general use and have very few of those sensitive species present. And we do have some new analyses we've developed that kind of illustrate that relationship. So, you know, if you want to meet the excellent threshold, which there's really no mandated reason to do that in Illinois because they don't have tiered aquatic life uses. But we felt we had to simulate at least the positions of where tiered uses would occur just to get to first base with this concept. And but so it's important to understand, just because we keyed it on, and there's going to be a different set of sensitive species depending on the parameter. Each parameter is going to have its own set of most sensitive fish and macroinvertebrate taxa. There are probably some taxa and fish species that show up for almost every one, but they do vary. So it was keyed independently of the IBIs first, and then that was snapped back to the IBI thresholds because those are the current legal way of defining impairment in Illinois streams.
And maybe one thing I'd add is I think the way we see it working is that the thresholds, we don't see them being used sort of standalone in a sense, so that you would look at, the first thing you would say are, do you have impairment? So that, you know, that one slide, the box and whisker plot that Stephen showed, had some, you can have some, you know, you may have a site where you have a nutrient, for example, above the threshold, but we wouldn't necessarily consider that impaired. We put it into what we call threatened category. So you want to consider whether that is likely to have an effect, but we don't consider it necessarily impaired because that threshold is exceeded. If the biology is attaining that use there. So it's the way I think that it's structured in terms of looking at risk is you look at whether it's impaired or not. And we know that you can potentially have situations where you have the biology attaining and you have maybe a slight exceedance of a chloride or a phosphorus threshold that you would then consider in terms of, you know, whether that's a real risk or not. You look, you know, more deeply into the data or nearby sites and so on.
I might add, this is Doug again, just to emphasize that point. You know, that particular observation that Ed just described is, you know, consistent with how nutrient water quality criteria have been developed, and recommendations for how to put those, you know, what process do you go through to put a water quality standard together that relates to nutrients. You know, state and throughout the US has recognized that there is some correspondence between higher nutrient concentrations and adverse biological responses, but there is scatter in those data, and the outcome of that eventually has been this kind of combined criterion approach where if a numeric threshold for a nutrient concentration is exceeded before something is assigned as impaired, the biological data need to be available and compared with that management threshold. And so I think what Ed described is how IPS deals with that particular topic.
So, Dina, I have a question.
That's fine. Go ahead.
Yeah. So, Doug, going back to your point about algae, and you know that is obviously a critical component in we'll call it the expression of nutrients toxicity to aquatic organisms. You know, the relationship, obviously, well, just stating the relationship between nutrients and algae itself is a relatively messy one. So I guess I just like a couple of thoughts on the value. You know, our endpoint is the attainment of these biological goals as measured by IBI. So I'm just wondering, I guess I would say there's a risk to also spending a lot of time looking at algae where you could end up not a lot further forward, but having, you know, collected a lot of additional information, but not necessarily understanding the problem that much more, or perhaps having a finer tool to improve aquatic life.
Yeah, I think I would answer your question this way. You know, having that data set, there are going to be two parts to my answer here. Having that data set will be important, again, in my view, to identify nutrients as a key stressor correctly, to make that correct identification in more cases, not necessarily for every case across the board, but for more cases, having those data will be useful. That's the first part of the response. The second part is, I think, and one of the recommendations that I've made, again, with my understanding of what has been done so far is to do more, even from literature or from other sources as they may be available, to connect the mechanisms between sensitive species, sensitive macroinvertebrate and fish species, and high nutrient concentrations. So, one example is the mechanism is the high nutrients lead to proliferation of algae species, including such and such, that take over the benthic community, and these macroinvertebrate species can't deal with that habitat, therefore. So that's something that I think could be useful in the absence of algae data, to help better connect the threshold values to the, that is the nutrient concentration values to the macroinvertebrate and fish IBI values.
Yeah, this is Ed again, and I appreciate those comments. I mean, one of the things that we didn't get a chance to do, I think there is more information in the biological data than we've wrung out, I guess, in a sense. So, for example, one of the aspects that would be, we thought we could include is some consideration of like traits. For example, for a fish, more specialized insectivores, or how omnivores and detritivores may vary with some of these nutrient signatures. And, and if you tend to get more, if we do get more benthic chlorophyll data, you could use that to explore how that relates to the macroinvertebrate. I'm not sure we have quite as good a handle on the traits of all the macroinvertebrates, but you could use that to see, are there invertebrates that decline with, where you have a very high benthic chlorophyll signature. So you could use this to help identify sort of other useful nutrient signals. And I think with the DO data, I think that's one where I think is maybe more quickly we could build up we sort of have a data set we're building up of more continuous DO data. I think that's sort of a weakness in the stressor data, is probably the grab DO is sort of it'll give you a signal if it's very low or very high, but the intermediate values may not really reflect the conditions of dissolved oxygen, which can be, again, one of those mechanisms that can be important with nutrients. So I think there's things that will improve our ability to deal with the nutrients. Some of it may be already in the data, and other things are again, these other data sets that might be useful.
Yeah.
Yeah, just interjecting on that point, I guess these comments also go somewhat for algae, but looking at 600 sites, and so the issue with DO, just for anyone who isn't looking at these plots on a day-to-day basis, is you have these diurnal fluxes of dissolved oxygen. So you can go in the morning and take a dissolved oxygen reading, get one thing, come back in the afternoon and get another. We see there's a much higher level of predictable variability with dissolved oxygen readings than there are with say the chlorides or something, where you could take that sample throughout the day and see very little variation. But so that's why we moved to these, and as Doug pointed out, these continuous dissolved oxygen figures, and that's where we're taking regular, say every 15 minutes, every hour, every couple of hour type samples, using some sort of data logger. But once again, trying to put that in at 200, 300, 400 sites becomes an exercise so vast that it's, I'm wilting a little thinking about it. So in some ways we're doing the best we can with data that we can produce and replicate across a wide variety of sites.
May I should update you on what we're actually doing, which probably a lot of people aren't aware of, but since 2017, we started collecting the data ingredients for what's called a SNAP, modified SNAP type of procedure, and SNAP would stand for Stream Nutrient Assessment Protocol, and it really emanates from Ohio. And we started that in the Upper Des Plaines, so we've done it for 3 years now. And we've also have 2 years in the North Branch, Chicago River watersheds, and we have 2 years in the Lower Des Plaines. And Stephen has started a program for the DuPage watersheds. So we're a little bit further ahead in the Upper Des Plaines, and we've actually attempted a multi-parameter assessment, just looking at the array of contributors that would signify that there is indeed an effect of nutrients, an adverse effect of nutrients, and have tried to put that into categories like not no enrichment, slight enrichment, all the way up to severe enrichment. And we still have to determine at what point would you take an action to reduce nutrients, and where would you do that? And so we're learning as we apply it in assessments. And maybe one of the better ones to look at when the report becomes final is the 2018 Upper Des Plaines main stem. It is wastewater dominated, but it also has an interesting non-point source lead in the upper watershed, where the nutrient effect is totally non-point source, and then all of a sudden you shift to point source dominance. And it's really kind of an interesting response, and it was somewhat surprising to us. The other thing, and this is very preliminary, but we are looking at both benthic and cystonic chlorophyll A. And right now, we're not getting a huge response out of either one. It's a little bit puzzling. And I'm kind of starting to hear the same thing from the people at Ohio, that what they thought was a tight fit may not be as tight as it could be. But where we are seeing something happening is in the DLDO regime. We're seeing responses there, but how that's happening without the algal indicators is kind of a mystery. It could be, it could be aquatic plants. I don't know, but these, these recommendations that are made, we're definitely acting on them. The other thing is that I think what we need to do is translate everything over to the DO regime, because that's the direct effect on the aquatic life. And right now we're dealing with aspects of the DO regime that we haven't dealt with. Traditionally, we've always dealt with low DO as a problem. We've never dealt with a wide DO swing. And when does that become a problem? When does that day to night swing become too much? And then presumably it being related back to nutrient loading. Fortunately, Illinois EPA has routinely collected continuous DO data at a lot of their sites. So we may be able to do like what we did with the other parameters in the IPS, go out and kind of forage for their data and their corresponding fish and bug information to get a better gradient than what we might have in our watershed group study areas. The last thing I'll say is that when we talk about algae, we got to be certain we're talking about, are we talking about chlorophyll, or are we talking about the assemblage of algae? And I think here, what everything I've heard, it's the chlorophyll aspect of algae. But I think we throw that word around a lot. We've got to be, some people would think you're doing a full algal assessment. And that's currently not an endpoint in Illinois.
Stephen, this is
I have a question for you. Do you know if the 2018 DRWW report has been released yet? Is it final?
No, it's in, we're in the final stages of revising it, and it's been a draft for about 6 months now. So the pandemic slowed things down. Normally we would have had it finalized by now.
And Chris, that will be available on their website, I assume, once it's released. We can notify.
Yeah, and I don't, is anybody from DRWW on the call?
Yeah, there are some people from Lake County on the call.
Jacob on the
Actually, I don't know. I don't see anyone's name anymore, that we're losing people, but I have 2 phone numbers that I don't know who those people are, but
yeah.
None of the representatives are.
But I mean, that's the other aspect of this whole thing is we're continuing to do detailed watershed assessments. And that's going to be where sort of the rubber meets the road with this, with at least part of the IPS tool. And it's what's going to lead this iterative collection of data is going to be the feedback mechanism to what we thought we knew 5 years ago. It may verify some things, it may change some other things, but it's all part of the adaptive management process that, you know, the groups have fully invested in.
Stephen, this is Mark again. Through this conversation, I keep taking a step back a little bit sometimes and looking at some of the conversations around the details here. Then I think of kind of the practical aspects of some of the stream restoration projects that are underway or have been completed. And I think what was clear in some of the early aerial photographs you were showing before Doug and I began to speak is there's going to be a lag time, obviously, in the stream response once the restoration is complete. And I think of the benthic algae. We've been in river systems where you have a fairly shallow, fairly wide, no riparian cover, and light temperature and nutrients are just ideal for something like buffer growth attached to algae. And we see some of the most severe diurnal DO swings in those conditions. And so much of that is there's just available sunlight and nutrients. And so I'm just thinking about in the context of timing of when the scoring is done for a restored site and how mature vegetation do you have in the riparian zones. And that takes time. And so I think that time lag is one of those interesting perspectives in the conversation here in terms of stream response. Yes,
time after a restoration and also time of the year that you're doing such analyses. You know, I have, well, we've all seen the sort of dissolved oxygen studies saying, well, we improved dissolved oxygen and using a few grab samples to show that. And, you know, that we can all debate if that's a proper vindication that a project X actually improved dissolved oxygen because I don't know what time of day those samples were taken at, and, you know, that the N was very low and such. So, yeah, your point's well taken, Mark. Yeah.
But I think that's the benefit of the continuous DO measurements, because if no one's out there at 5 a.m., you have the respiration cycle. It wouldn't be representative necessarily than late afternoon if you do have a lot of chlorophyll A in the system.
Well, right now the protocol is that we do short-term deployments of sondes, but we do it fairly intensively along a main send. For example, in the Upper Des Plaines, we had 18 biological and chemical sites, but, you know, we only had 7 data sondes at our disposal, so we did 2 sets of 7, did 14 sites. You know, if we had 10 data sondes at our disposal, we could have done all the sites. but so we had to prioritize. But I mean, these are some of the realities we're running into with this type of work, and depending on the comprehension of the issue by each group. But of course, everybody's facing the NARP issue, but there's a little bit of variation, I think, in how each group is addressing it, and that may need to be tightened up a little bit.
Yeah, so the data that we're collecting there, as you know, signified by the SNAP, and we're also doing it, we're tying it to the bioassessment, so the biological data would be available, and we're integrating that with the bioassessment. So Doug, is that the kind of information that you're thinking? We were talking about the additional validation, that kind of information could be used to do that validation?
Yeah, I think that's included on a short list of validation type of approach that you could take. But I think what Chris described a couple of minutes ago of where the rubber hits the road is being able to look at how things perform with new data that are being collected, how the model performs specifically, and in different kinds of situations.
Yeah, and I'll add something to that, and something you said, Doug, about a nutrient criterion not necessarily being this really bright line that you can exceed and not have harm, and that's where the application to permitting is going to be critical. And for the first time, we have started to see sites fully attain the Illinois biocriteria. And we've been counting that as sites where both the fish and the bugs meet their biocriteria. We had 5 sites on the Upper Des Plaines main sim do that last year. And that's a first in ever. And I think we've had a couple sites in the Lower DuPage. So in those cases where you're able to show sustained attainment, even though you might be eclipsing that supposed bright line criteria, there has to be an out for that. And that's where this weight of evidence approach comes into play. I mean, and again, this is where the frailties of the Illinois water quality standards don't address something like that. But if you're in Ohio, there's absolute codified language that allows that to take place. And that's how they're pursuing it right now. They're giving entities the opportunity to show that, yeah, I'm not meeting the phosphorus number, but I'm protecting the designated use in the stream.
Right. Now, I would say I think Florida is another example of that, where that same kind of thinking is actually being applied to the permitting process, going beyond the way the combined criterion are used in the state's water quality assessment process, which is obviously also important. But then the question is, how do those situations get played out with respect to individual permit limitations? And I think it's important and also new ground in a lot of ways, I think, at least for many states.
So we are running up against our time. Actually, I passed our time a bit here. Dina, I assume we were scheduled at midday?
Yeah, we're fine.
Okay.
I mean, if there's more, I have no more questions that have been submitted to me on my end.
I do have one. I don't mean to hear every human line, but I've one just profiting from everybody's experience here. One of the questions I had was about downstream impacts of phosphorus. So one of the items that I often hear is when we're looking at anything to do with phosphorus, it's like, well, okay, it may sort of go to your point, Chris, that, you know, so we're still protecting biology here. Say, well, yes, but that phosphorus is going to damage biology some indeterminate point downstream. Now, I caught a comment from you yesterday.
That is Well, that's an issue, and that's a question that should be asked here. And you know, it's the classic near field versus far field effect. And far field would be, I mean, it's what we have in the Western Basin of Lake Erie. And you know, what we don't want to do is evaluate it only in near field terms and say everything's okay, and then end up causing a problem down in another water body. It's going to happen in a more static lake type system. I wouldn't rule out downstream effects in the Illinois River where it's impounded for navigation during a low flow year. And so if that's the case, that could end up controlling phosphorus limits, which I'd assume would be more stringent than what we would come up with for near field purposes. I think too, we were involved in an evaluation of how states are dealing with nutrients in the Gulf of Mexico hypoxia issue. And the emphasis there is on nitrates, but I think the only watershed that we saw that was point source, at least a major contribution port sources, was the Des Plaines water. Everything else was non-point dominated.
Interesting.
Yeah. That's I don't know. I can't recall the report right offhand, but I could dig it out if somebody's interested in it. I wanted to thank Doug and Mark for their work, their insights, and we haven't gone through the full package yet because we just got it.
Yeah, I apologize. I thought I'd send it.
I don't want to make Stephen look bad here, but so the other thing is we're in the throes of trying to get this, at least the current version of the IPS, get a document out. We do not have a unified document for that yet. What you reviewed was a major piece of it, but there's a lot more to it than that. Right? Some things to think retrofit. But I think we're at the point where we have to go with it, acknowledging that yes, we do have to have the opportunity to kind of keep re-examining this as we go along. The good news is we're producing new data on each watershed about every 4 years. And Mark, for what you brought up, that's critical to have that frequency of revisit. A lot of states are rolling way back from that. Ohio's back now to where they're going to revisit watersheds every 12 years. So,
well, being able to do it on every 4 year or some sort of higher frequency like that is the best opportunity. There's no guarantees in any of this, but it's the best opportunity to be able to refine the magnitude and nature of the response given
I agree.
The concentrations of nutrients observed. So that's a key opportunity for sure.
Well, it's not about nutrients. We've been pretty amazed by seeing incremental responses to some of the habitat restoration projects.
Right.
And so that gives us some hope that, you know, we'll see a trajectory of, and it's tough in these urban areas because of the other limiting factors.
And Dina, Doug, I think that is one of the keystone points that was just made. Is one of the interesting things that you guys are doing is these are very substantial projects.
Mark, I think we just lost you.
I can still hear.
Okay. These are very substantial projects that are being implemented. And I think in contrast, again, and I keep going back to the traditional trading is, if you're trading lake for lake, you're still trading in the margins in the noise. You're still trading in mass reductions of phosphorus that likely have very little meaning in terms of water quality response, as opposed to the physical restoration of the stream channel itself. So there's a scaling consideration there in terms of this approach, whether or not the IPS or other indices can 100% say, hey, we nailed it, versus what you may say of trading even between point sources, where your small incremental reductions likely have very little impact in the stream. So I think just kind of a big picture perspective, I think that's really what's kind of cutting edge in this overall shift towards how this tool is to be used, but also this notion of the stream restoration as mitigative approach to small reductions in phosphorus elsewhere. So I think that's a remarkable consideration here in this process. And so that even though there is some noise, there are signs of some strong correlations and some clear indicators here that I think there's great merit in how to propose this as the Conservation Fund representing the state group is looking to do this.
Totally agree.
Well, Dina, I think instead of keeping everybody all day, I think we'll wrap it up.
Yep. Sounds good. There's no more questions.
We may want to have some follow-up here in a week or two.
Yes, I agree.
Ted and I can really plow through everything.
Yeah, I agree. And also,
and I met with Mark and Doug.
Yeah.
Yes, understood. Yeah, you and I have some follow-up nearly immediately to do.
And we'll share the memo with the projects committee too, so that you guys can all see it.
Okay. Well, with that, thanks everyone for attending and valuable time.
Thank you.
And I hope you all gleaned information from this. So for Doug and Mark and Ed and Chris, thanks so much for taking time to talk us through all this.
Thanks.
Thank you very much.
And
Much appreciated.
for our attendees that are still here, don't forget, we'll have another one of these fascinating project committee meetings next week focused on the physical projects. Update on Faywell. Boyd Kennard's going to be there to present, I think, some potential sketches. Stephen, you can correct me if I'm wrong. We have a lot of renderings and stuff to share with you on Growy Mill. And I feel like there's, and some questions that needed to talk a little bit about our Qual 2K model. So I'll be sending out another Zoom invite to that later today or on Monday.
Thanks, Dina.
Thank everybody.
Take care.
Have a good
Bye-bye.
weekend, everyone.